Now, ladies and gentlemen, we'll be just reminding you to move on to the next session. This, of course, is going to be the special session 1 for our online audience. It is time for you to click on special session 1 indeed and to get yourselves organized for this next one. I would like now to invite for this next session. In fact, the subject matter is decarbonization and low carbon solutions. Coming through to us virtually is the Honourable Dr. Megan Woods, Minister of Energy and Resources, New Zealand, to deliver her keynote. Megan, over to you.
Kia ora and good morning, everybody. I'm very pleased to be here virtually at the Singapore International Energy Week, and I'd like to acknowledge the Singapore Government, the Singapore Energy Market Authority, and the Ministry of Trade and Industry for organising and supporting the Singapore International Energy Week. Thank you for inviting me to deliver a keynote at this session. The session discusses two key themes: the role of low carbon alternatives in decarbonising our energy systems, and the role of transitional fuels in bridging the gap to low emissions economies. We know that no matter where we are from, the energy and industry sectors play a central role in our lives and in our economies. We also know that while we are making progress, big strides must be made to get an affordable and a sustainable low emissions world. And as these sectors transition, we must ensure that energy remains accessible and affordable, energy supply is secure, resilient, and reliable, and energy systems support sustainable economic development. Increasingly, the share of renewable energy in our respective energy systems will play a critical role in this transition. Despite the COVID-19 pandemic, more than 260 gigawatts of renewable energy capacity was added globally in 2020, beating previous records by almost 50%. According to the International Renewable Energy Agency, more than 80% of all new electricity capacity added last year was renewable. Solar and wind accounted for 91% of new renewables. These numbers tell a remarkable story of resilience and of hope. Despite the challenges and uncertainty of 2020, renewable energy emerged as a source of undeniable optimism for a better, more equitable, resilient, and just future. However, we all know there is more work to be done. Governments must focus on safeguarding existing renewable projects, distributed generation investments, and renewables-ready network infrastructure. We must also ensure stable policy and regulatory frameworks for transition-related infrastructure. Policymakers should actively steer investment away from the fossil fuels industry or carbon-intensive projects. Instead, incentivising and supporting the development of renewable energy projects and the use of low emissions fuels such as hydrogen and bioenergy. In addition to renewable sources such as wind, solar, hydro, and geothermal electricity generation, use of low emission fuels such as bioenergy and hydrogen will be critical to decarbonise the energy system. Hydrogen has emerged as an important part of the clean energy mix. Production costs are falling, and combined with the urgency of cutting emissions, hydrogen now has an unprecedented momentum. With low carbon green hydrogen, we have opportunities to create new jobs, convert heavy transport away from fossil fuels, and enhance our security of electricity supply. Together, renewable electricity and low carbon hydrogen provide a robust energy system platform to help decarbonise our countries, delivering benefits that neither could do alone. Government and industry must work together to ensure that existing regulations are not a barrier to investment. International cooperation is also crucial to the development of a global hydrogen economy. Here, I'd like to acknowledge the arrangement of cooperation on low carbon hydrogen that New Zealand recently signed with Singapore. The arrangement builds on the Singapore-New Zealand Enhanced Partnership signed in 2019. and marks the start of a journey between our two countries to collaborate on the production, deployment, and research into a new hydrogen economy. Bioenergy is another source of renewable energy contributing to energy used in power generation, heat for industry and buildings, and also for transport. International Energy Agency modelling indicates that modern bioenergy is an essential component of the future low carbon global energy system if global climate change commitments are to be met. Biomass has significant potential and can be directly burned for heating or power generation, or can be converted into oil or gas substitutes. Liquid biofuels, a convenient renewable substitute for gasoline, are mostly used in the transport sector. Therefore, countries could consider more active support for development of larger scale bioenergy and hydrogen industries to enable emissions reductions in the process heat, electricity, and transport sectors. Supporting the development of new green technologies and research and innovation will also play a critical role in transitioning our energy systems. Recently, Araake, New Zealand's Energy Development Centre, signed a partnership with Singapore-based Ecolab Centre of Innovation for Energy to establish real-world technology demonstration sites, also known as test beds, for validating innovative low-emissions technology at scale in New Zealand. In addition, GNS Science New Zealand is looking at possible collaborations with Singaporean researchers related to fuel cell systems, hydrogen-powered distributed generation, and combining hydrogen production with geothermal energy. GNS Science is also collaborating with Nanyang Technological University, Singapore, on a research program. As we transition our respective energy systems, transitional fuels will continue to play an important role. Fossil gas is one of the mainstays of global energy, but as we consider phasing out its use and associated infrastructure, it will be important to ensure the method and speed of transition maintains security of energy supply and prevents adverse or unexpected effects on consumers. Increased uptake of renewables, energy efficiency, and related energy transition measures represent future thinking investment amid the crisis set off by the COVID-19 pandemic. As part of short-term stimulus and COVID-19 economic recovery plans, the energy transition provides a crucial link to medium and long-term global and sustainability goals. A combined effort from governments, public and private sectors, industry, and communities is required to reduce emissions and build a secure, affordable, and sustainable energy system that supports the well-being of all individuals. It has been a pleasure being the keynote speaker at this session. Like you, I'm eagerly looking forward to the exchange of ideas in the panel session. And I'd like to acknowledge Dr. Joey Saldanha Dalla Evdigo Gamlaba, the Deputy Minister and Secretary of State for Energy, Portuguese Republic. Yoshiyuki Hanasawa, the Executive Vice President and Chief Regional Officer for the Asia Pacific and India at Mitsubishi Heavy Industries and Managing Director of Mitsubishi Heavy Industries Asia Pacific, and the moderator, Gosui Chen, Chairman, NTU Board of Trustees. Thank you.
Thank you very much, Minister. And now on to our next keynote, ladies and gentlemen. This time, I'd like to invite Andrew Light, Assistant Secretary for International Affairs, U.S. Department of Energy, to deliver his keynote.
Hello to my friends and colleagues in Asia. My name is Andrew Light. I'm U.S. Assistant Secretary of Energy for International Affairs. I'm thrilled to address this year's Singapore Energy Summit. I would like to thank the Singapore Energy Market Authority for organizing this event and inviting me to speak to you. I'd like to speak today both about the threat we face with climate change and just as urgently, the opportunity we have in front of us to accelerate the global transition to clean energy solutions that can create good paying jobs and prosperity for decades to come. I think you all know that no Asia-Pacific nation is immune to the impacts of climate change, nor is the United States, and the escalating economic costs that we're all seeing today. What's clear is that we can't afford not to act. and we must collectively do everything we can to limit global temperature increase to 1.5 degrees Celsius. President Biden understands the urgency of the climate crisis. It's why he set ambitious goals for the US to cut our emissions in half by 2030 and reach 100% clean electricity by 2035. That's why the US Department of Energy has been doubling down since President Biden's first days in office to help meet these goals. We're working hard to reduce costs and other barriers for the key breakthroughs we'll need to reach net zero globally, like clean hydrogen, long duration storage, better batteries, and much, much more. Solar and wind, for example, are now cost competitive with fossil fuels, sparking a clean energy revolution around the world. Last year, renewables made up 90% of new electricity capacity added globally. Clean energy is the future, not only because climate science demands it, but because it's the biggest economic opportunity we've seen in a generation. The global market for clean technologies will be worth $23 trillion by 2030, and that's at a minimum. That means new industries, new jobs, new investments, but only if we seize the moment. The United States is fully committed to doing our part to speed the global energy transition and to help the rest of the world do the same. We see Southeast Asia as an incredibly important partner for climate and clean energy collaboration. That's why the United States and Singapore launched a US-Singapore climate partnership when Vice President Harris visited in August. And it's why, with Singapore's help, we launched the first annual US-ASEAN Energy Ministerial between Secretary Granholm and her ASEAN counterparts in September. With the region's energy demand nearly tripling by 2030, policies set in place today will determine if the energy mix remains fossil fuel dependent or if ASEAN partners, with help from other countries, can transform the energy supply to clean sources. While the transition to clean energy accelerates, now is the time to tackle the most powerful greenhouse gas, methane. Rapidly reducing methane emissions is the most effective strategy to limit global warming in the near term. President Biden announced at the Major Economies Forum meeting that the United States and the European Union are enlisting countries in a global methane pledge to be launched at COP26. We now have 50 countries on board. Parties signing on to the pledge agree to take national level voluntary actions to contribute to a shared effort to reduce global methane emissions across all sectors by at least 30% from 2020 levels by 2030. We're looking for more partners to join us by COP26. We thank our partners in the Asia-Pacific region that have already signed up for the pledge, including Japan, Indonesia, and the Philippines, and we encourage others to consider joining as well. We look forward to working together as an Asia-Pacific region to address the climate crisis and transform our energy systems, creating opportunity and millions of good-paying jobs. Thank you very much, and I hope that the rest of the conference goes well.
Thank you very much, Mr. Light. And now, ladies and gentlemen, Minister Megan actually briefly introduced our next panel, and I'm going to mention who they are right now as they make their way up on stage. We have His Excellency Dr. João Galamba, Deputy Minister and Secretary of State for Energy, Portuguese Republic. Joining him is Mr. Yoshiyuki Hanasawa, Executive Vice President, Chief Regional Officer for Asia Pacific and India, Mitsubishi Heavy Industries. And moderating this panel, ladies and gentlemen, is Ms. Goh Swee Chen, Chairman, NTU Board of Trustees. Ms. Goh, I'll leave the floor to you.
Thank you very much. I think it's already good afternoon. Good afternoon, everyone. I thank you for your attention here today. We have, over the past few years, there has been countries, corporations, racing towards making pledges on carbon neutrality or net zero. And in this particular session, what we want to do is to focus on solutions. So the session is on decarbonization and low carbon solutions. We want to move from pledges now into actions. And we have two eminent panelists here. His Excellency, Dr. João Galamba, Deputy Minister and Secretary of State for Energy from the Portuguese Republic, and Yoshiyuki Hanasawa. EVP and Chief Regional Officer from Mitsubishi Heavy Industries. And I would like to start the first question to Dr. Galamba. You've made a pledge, and you are the first, actually, country to make this pledge towards carbon neutrality by the year 2050. And you now have the National Energy and Climate Plan 2030. How is Portugal working towards the objectives of this plan?
Well, we're trying to basically adapt our legal and regulatory framework to sustain a speed up of our renewable deployment. Basically, we've committed to more than 80% of renewables in our power sector by 2030 and 47% of renewables in final energy consumption. And according to the Portuguese regulator, with the licenses that were already awarded, we will beat the estimation and will achieve our goals in the power sector in 2025. So in Portugal, what we're trying to do is, because in Portugal, it's clear that decarbonisation and deployment of renewables are a clear growth strategy, we want to do it as soon as possible. We have nothing to lose. We don't have coal, we don't have gas, we don't have oil, but we have a lot of sun, a lot of wind, and we have good hydropower. So for Portugal, the answer is very simple. We will go as fast as we can, because the faster we go, the higher we'll grow.
Yeah, and the sun in Portugal is famous, right? That's why you have tourists
Yes.
flocking, and now you're harnessing it for different reasons.
And we did two solar auctions in 2019 and 2020, where we had the lowest prices in the world. Now we were only beaten by Saudi Arabia. I think it was in a previous panel, it was mentioned that Saudi Arabia got 10 euros per megawatt hour, we got 11 euros per megawatt hour. And we're not a desert country. We are a Southern European country, but we and Spain are by far the most competitive European countries in renewable energy, and we're taking advantage of that.
So Dr. Gallenberg, I asked just one more question specific to this. You said we have nothing to lose, and you're saying, well, your goals, you've set it for 2030, you're going to be ahead of time. And you say that the goals could be achieved by 2025.
Yes.
What were the drivers, or what were the conditions that allow you to go at such great speed?
Well, we were early movers in wind power in the early 2000s, and we installed a lot of wind capacity, mainly until 2010. But I think the biggest driver is that it's cheaper to produce power using. We have a good story to tell consumers. Mm-hmm. When we say to consumers, look, now with carbon taxes in Europe, even in normal conditions, not the ones as we see today with gas and coal, but in normal conditions, producing electricity from hydro, from sun, and from solar and from wind is the cheapest way to produce power. So it's not easy to sell to the Portuguese people that we need to deploy this as fast as we can, because it means good news for them. It means that they will pay less in their power bills for domestic consumers and for industry. So we mobilized all the stakeholders in Portugal because we believe that all stakeholders have something to gain from this speed that we're trying to impose. And so far, I think things have worked fine for Portugal. We just have to continue with our hard work, but it's a rewarding work.
Yeah, that's exemplary. I move on to Hanazawa-san. Hanazawa-san, MHI's vision, and I read it, is to solve society's issues through global integrated engineering, ensuring long-term well-being and security for humanity. It's a really lofty vision. And you've been doing a lot of work here in the area of decarbonization. So why is it so important? Why is decarbonization important to MHI?
Yeah, thank you very much for the question and the opportunity. I'm very happy to be with you here. And MHI, our mission is to solve the social issues of the day. And our CSR guideline stipulates that through our technology and the business practice and our people, we cure the earth and to create more harmonious society. So the decarbonization is exactly what we have to do. And the actions from the industry to contribute to hydrogen society. Let me say something about the detailed action which we take. So when I simplify the hydrogen ecosystem as a value chain, the production, transportation, and usage. We work together with our partner, it's a collaboration. For production, we now invest money to the technology holder in Norwegian company for the electrolyzer technology. Also, we invest money for the Australian venture company. They generate green ammonia, green hydrogen. We can check how they will improve the cost competitiveness through this project. In the transportation, MHI, because of our experience, we prefer ammonia, not the MCH or not the liquefied hydrogen. And the usage, there are three main sectors. Number one, power generation. Secondly, industries. Number three, maybe mobility or ships. So power generation, it's our core business, and we are good at the burning technology. For example, we have experience and knowledge using liquefied hydrogen for the rocket engine for space. And our number 44 rocket will launch maybe tomorrow. And we have already reached 30% hydrogen mixture with natural gas already in Netherlands. And we aim to achieve 100% in 2025. We also developed the smaller gas turbine or gas engine, which could be used for the industry like data center. And also, if we bring ammonia, we can use this ammonia in today's coal-firing power station, so reduce the CO2 emission. And we also developing the ammonia-firing gas turbines. The industries, mainly we think about the steel-making process. They use coal, so we like to switch to hydrogen. Then we started the testing in Austria, and also we will start to conduct a joint study with Australian Institute. So number three, the mobility or ships, especially ships, we think ammonia is a very good alternative fuel for ships because it uses large volume and the carbon neutral. Especially in Singapore, it's a very huge bunkering business here. So I think ammonia is very critical for Singapore. Let me add one thing for the CO2 capture ecosystems. The hydrogen, we can imagine the hydrogen society, it's a kind of the replacement of the fossil fuel. But the CO2 capture, it started very recently. Somebody said currently the man emit the carbons 40 billion tons per year, and we capture below 1%, very small. So we have to make it balanced at under level. So what I want is to enlarge the volume of the CO2 capture. MHI, we're proud of now 70% of market share of CCS with us. We have the world's largest carbon capture plant in Texas, Houston. But it's very small. So how to enlarge this? We need to create the market. We need to create the business. And we encourage the people, we will motivate people to start CCS projects. One of those which we started with IBM in Japan. We like to create a digital platform using AI or blockchain or IoT so that we can monitor and visualize the flow of carbon, captured carbon. And I think such will be used, for example, the issuance of the certificate in the future. And we like to add value to CO2. So we just started activity, but already many companies show interest in joining us. Thank you.
Yeah, and very promising solutions. And Dr. Galamba, just this one, because you are an early mover in hydrogen. And how are you supporting all these the global efforts in hydrogen, in low carbon technology development?
Well, we were we were early movers in green hydrogen because we are competitive in power generation using renewables. That was the key driver. So the thing that got us started was the results in the auction of 2019, when we got an average tariff around where it was 1 gigawatts that we assigned in that tender, and the average tariff was 20 euros. So that got us started in hydrogen. So basically, what we're doing now, we've already adapted our legal framework to allow hydrogen production, distribution, usage, and storage. We're basically targeting for heavy industry and transportation, road transportation, air transportation, and maritime transportation. And we already opened a 40 million call to support the first projects. We've opened a second call of 60 million euros to further increase it, and we are using significant amounts of our resilience and recovery program, which is the European program for post-COVID recovery, to boost hydrogen. And our key priority is mainly in 2 hubs, one of them in our deep sea port of Sines, and we're targeting their production of green hydrogen at low cost. Basically, with the targets of prices that we're looking at in Portugal are always below 3 euros. We actually have a Portuguese technology, a company called Fusion Fuel, that can currently produce at 2 euros per kilo, and in Australia with existing technology at 1.54. That's the latest numbers I saw. And basically, we want to produce as cheap as green hydrogen as cheap as we can, to use it in our own decarbonization strategy, and to become net exporters of energy using mainly our ports to export it to the Northern Europe, where competitive conditions for hydrogen productions are lower. So we have several projects. We are approaching it in a cluster way because there are strong synergies in having hubs where you can, in the same location, have production, shared storage, usage. So in Sines, which is the deep sea port in the south of Portugal, we have a large refinery from Galp, a Portuguese company. We have a large chemical or petrochemical company from Repsol, and we have other companies. They will be users of hydrogen, so we will locate most of our production there. And also in the north of Portugal, where we have our chemical cluster, they are advancing heavily in trying to substitute all the fossil ammonia that we import by a green ammonia that we can produce and then become net exporters. So we believe in the, and there's a huge compatibility between green hydrogen and power generation. So basically we're using hydrogen to complement the things that we cannot electrify. It will probably relevant for the power sector, also for long-term storage and for some balancing power stations. But we're mainly trying to substitute coal. We've already closed. Now we are trying to substitute, that will be slower, gas, using, of course, solar, hydro, wind, and in some applications, hydrogen. But I agree that ammonia and methanol are probably the priorities, because international logistics already exists. They are less challenging to transport and store, and they are a relevant energy carrier that can be used properly for deep decarbonization efforts, such as the ones that we're doing in Portugal. Thank you.
Yeah. So it's a really interesting discussion, and we are really talking about, I like what you said, nothing to lose, and Hanazawa-san, that conviction that technology would help with decarbonization. With that, we need to bring the session to a close, and I want to thank you both for your comments.
Thank you very much.
Thank you.
And thank you, Ms. Goh, for moderating this session. Thank you.